Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is basic process diagnosis tools. There are several tools on understanding the process diagnosis to establish the trends, interrelationships. These tools, if practiced on routine process, the results obtained would give you complete and comprehensive knowledge and behavior of the process. Let us try to understand few of such tools. Let us see basic tools. Few of the basic tools for diagnosis of manufacturing process include the following: cause and effect diagram, Pareto chart, scatter diagram, and histogram. These belong to basic tools that are utilized for routine purposes. Data generated by using these tools establish good diagnosis of the process understanding. The data can be effectively used to improve the skills continually. The first of the list, cause and effect diagram, focuses on the potential cause that has an impact on the process. This tool is useful for evaluating the cause, the potential reason that could lead to an effect, the impact on output. Every effect has a cause. The effect could be on the positive side or on negative side, but it is generally used for focusing on negative impact. FMEA or FMECA tools are used for evaluating the positive impact on the process steps. Each of the potential reason will have some impact on the next stage of operation. This is a chain reaction. Each cause will have an impact on the next stage of operation. The impact could be minor or major. This has cumulative effect on the final step. Each effect at each stage sums up finally to lead to the outcome. This tool works in a structured way and leads to a systematic way of diagnosis. This kind of structure will help to see that no identified cause is missed out of the focus. This structure operates systematically in a sequence. The structure works like a leading fishbone towards the head, the effect. The structure looks like a fishbone. That is why it is named as Fishbone Diagram. Easy to remember. The head of the fishbone leads to the problem, the effect. The illustration in the next slide will help you to understand better. This is a typical fishbone diagram. This is a typical failure of the product batch with impurities beyond acceptance criteria. The fishbone head is towards the failure. The first set of main causes are 1, 2, 3 and 4. Second set of main causes are 5, 6, 7 and 8. Second level of causes for 1, 2, 3 and 4 are 9, 10, 11 and 12. Second level of causes for 5, 6, 7 and 8 are 13, 14, 15 and 16. This is only a simple illustration. In this example, there are 16 identified causes that has contributed to the effect on the outcome. Depending upon the complexity, there can be more number of subsets and branches. It is important that no cause should be left out without identifying to get a comprehensive fishbone drawing to evaluate and design kappa. A brainstorming session is necessary to get good output. You can see details in this slide. Cause number 1. The dryer temperature shot up unnoticed. Due to this increase, the product got exposed to higher temperature. It is charred and deteriorated, giving out impurities. Point number 9 is second level cause. The steam inlet valve was the culprit. The valve failed. Because of this failure, the steam input to the dryer went uncontrolled, leading to the effect, the failure. Cause number 2 is wetness in the cake before loading into the dryer. Because of the higher wetness, the product got exposed longer at higher temperature, leading to generate more impurities. Point number 10 indicates that the wetness was not uniformly distributed across all trays in the dryer. This inconsistency was responsible for deterioration of the product. Point number 3 was next level. The centrifuge was not performing as expected. So the filtration was inconsistent, leading to inconsistent wetness across the cake in the centrifuge. The base was not fitted appropriately and firmly. This is reflected in point number 11. Point number 4 was chemistry related. Reaction completion was not as expected. It took very long time to achieve the target. In this next level, point number 12 indicates that the material used are not suitable quality. All these branches of investigation are useful for conducting the cause of failure. Let us see if any other points also may be investigated. Let us see in the next slide for information on the other side of the fishbone diagram. Having said about the failure of steam valve of the dryer and centrifuge, let us investigate into these two items. Point number 5 leads to a preventive maintenance of the equipment concerned. Poor preventive maintenance program led to the failure as equipment were not maintained properly in the state of repair. The reason was found out in the point number 13. It indicates that the SOP was not operator friendly. The operator could not understand well the operation. You must understand the intricate meaning of imperative and mandatory style. Refer Hydraulics Volume 4, Part 1, Chapter 4, Section 4.4 for guidelines for drafting operating instructions. Next point number 6 indicates that the operator was not trained on the job. Reading the SOP may not be adequate to perform well. It is like driving a car first time. If you are provided with an SOP on operation of a car, you cannot drive without hitting anything. You need hands-on practice. This is reflected in point number 14. Point number 7 leads to raw materials procurement system. Materials were procured from unapproved source. The quality attributes of the material supplied were not qualified. This was the reason for poor quality material procurement. Since there was urgency on procurement, the material was procured from an unapproved vendor. This is reflected in point number 15 in next level. Yet another point on resource management is noticed in point number 8. Insufficient resources were the limitation for carrying out job on time. Point number 16 in the second level leads to the effect of the inconsistent distribution of manpower. These are few points captured as identified risk elements. All these items must be detailed enough to make sure that the outcome is comprehensive. depending upon the criticality of the fishbone diagram, may vary significantly. Let us see how a Pareto chart works. This is a wonderful tool to evaluate the contribution of few causes that contribute to the total major problem. This chart is useful and gives insight to contribution of each failure and cumulative 100% information on failures. More than 80% problems will be contributed by less than 20% causes. This is true in many cases. Major contribution of failures are caused by very few issues. Pareto chart classifies and ranks the total problems by magnitude and frequency of occurrence. This chart gives you information on ranking of each failure separately. This tool helps to focus on the major causes to the effect and plan a strategy to resolve the major problem. This tool helps to focus on the reasons for major contributing failures and to design a suitable kappa. Let us see typical data for a product failure. In this example, SA failure and water content failure are ranked as major failures in the cumulative number. In some instances where SA is reported as its basis and KF separately. Here in this example, many failures are due to these two reasons only. Look at the other failures, failure due to impurities, CO test and bulk density test are very less. This information can be captured as a Pareto chart. One typical example in the next slide will help to understand better. Out of 38 failures, the major contribution from these two are 32. See this typical Pareto chart with the above data. This chart totally shifts the focus on the major two failures to resolve. Let us see the importance of the scatter diagram. This tool is helpful to identify specific relationship with each other within two variables. This is another important process diagnosis tool. This identifies a positive or negative relationship between two variables. Scatter diagram shows how much one variable is impacted by the other, the correlation. Correlation is an indication on how closely the two variables are impacted. When the data points are closer to each other, the higher the correlation between the two. If the correlation is closer to 1, it is considered as closer relationship between the two variables. If there is no specific scatter of the data points, it gives information that there is no correlation between these two variables. So, if there is no correlation in the scatter diagram, it is considered that two variables are not dependent on each other. Let us see how a typical scatter plot data for a positive correlation looks like. In this example, temperature of the dryer and the levels of impurities in the product are plotted. Let us see if there is any correlation or relationship between these two data points. Let us see the scatter diagram in the next slide. Let us see a typical scatter graph with positive correlation with the above data. See, there is positive correlation between the temperature of the dryer and levels of impurities. See the trend line? As the temperature increases, there is an increase in impurity level. This tool is a wonderful tool to get such information. Let us see a typical scatter plot data with negative correlation. This data is relationship between the SA as is basis and KF value. Let us see if there is any correlation between these two. It appears that more the KF value, lesser the SA value. See the scatter plot. There is downward trend line. SA value is dependent upon the coefficient inversely. This is called negative correlation. You can see the trend line is downwards unlike in the previous slide. Let us see an example scatter plot with no correlation. Is there any correlation in this data between yield and SA percentage? Let us see the scatter diagram in the next slide. Neither positive nor negative trends are noticed here. This is called no correlation scatter diagram. Histogram. This tool provides information on number of data points in different sets of data range. Let us understand what is a histogram. Histogram is like a bar graph. It accommodates numerical data into bins as columns and used to project the data set with a definite frequency. This provides information on individual contribution for each data range and cumulative frequency for all data points. This gives information on the population in each bin range. It can be evaluated whether or not the data is distributed in Gaussian curve with exact average center point. This also accounts for 100% cumulative score on all ranges of data ranges. This tool helps to find out the maximum contribution for SA content in a dosage form to establish the average content of the drug substance. This tool helps to establish the content of the drug substance in dosage form, whether it is at the midpoint of SA or if there is any drift from the average value. Let us see this typical histogram with cumulative frequency. In this example, majority of the batches are in the 98.5 to 99% range bin. Significant number of batches are in the bin ranges of 98.5 to 99, 99.1 to 99.5 and 99.6 to 100%. Only 2.5% is in the lowest bin range. Percentages at each bin stage are also provided in the cumulative line. Other important points to note: there are more such statistical tools to understand and carry out diagnosis of the process trends. Some include 5 whys, 6 sigma, gap analysis, value added analysis, etc. I hope that the information on few routinely used process diagnosis tools is useful. Try to practice such tools for your process to establish the process knowledge and recommend kappa if any improvements are necessary. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.